In this video, I will show you how to differentiate exponential functions. Let's say you have been told to find the derivative of 5 raised to the power of x. Whenever you have, let's say, the derivative of a raised to the power of u, this will be equal to a to the power of u and then times u prime times natural log of a. So in this case, a equals to 5 and then u equals to x. And if we differentiate this, u prime will be equal to the derivative of x, which is 1. So this will be equal to a to the power of u, which will be 5 to the power of x, and then times u prime, which is 1, and then times natural log of a, which is 5. And so our final answer will be 5 raised to the power of x times natural log of 5. Now you try out this. Differentiate 8 raised to the power of x to the power of 4 minus 1. In this case, a equals to 8 and then u equals to x to the power of 4 minus 1. And if we differentiate this, u prime will be equal to the derivative of x to the power of 4 will be 4 times x to the power of 3. And the derivative of negative 1 is 0. So this will be equal to a to the power of u, which will be 8 to the power of x to the power of 4 minus 1, and then times u prime, which is 4x to the power of 3, and then times natural log of a, which is 8. Now let's say we had the derivative of 3 to the power of x cubed minus 2x to the power of 2 plus 4. How can you differentiate this? In this case, a will be equal to 3, and then u will be equal to x to the power of 3 minus 2x to the power of 2 plus 4. And if we differentiate this, u prime will be equal to the derivative of x to the power of 3, which is 3x to the power of 2, minus 2 times the derivative of x to the power of 2, which is 2x, and then plus the derivative of 4, which is 0. And so u prime will be equal to 3x to the power of 2 minus 4x. So this will be equal to a to the power of u, which will be 3 to the power of x cubed minus 2x to the power of 2 plus 4, and then times u prime, which is 3x to the power of 2 minus 4x, and then times natural log of 3. Now what if you were told to find the derivative of e to the power of x? How can you solve this? In this case, a equals to e, and then u will be equal to x. And if we differentiate this, u prime will be equal to 1. And so this will be equal to a to the power of u, which will be e to the power of x, times u prime, which is 1, and then times natural log of e. Now natural log of e will be equal to 1. This is because ln is the same as log base e. Therefore ln e is the same as log base e of e. And from the rules of logarithms, if this is the same as this, then the function will be equal to 1. So this will be equal to e to the power of x times 1, which is equal to e to the power of x. Therefore, whenever you have an exponential function with base e, the natural log part will be equal to 1. So we can simplify our formula and say that whenever you have the derivative of e to the power of u, this will be equal to u prime times e to the power of u. Now let's look at some examples. Find the derivative of e raised to the power of x to the power of 5. In this case, u will be equal to x to the power of 5. And if we differentiate this, u prime will be equal to 5 times x to the power of 4. So this will be equal to u prime, which is 5 times x to the power of 4, and then times e to the power of u, which is x to the power of 5. And that's our answer. Now you find the derivative of e to the power of x squared minus 2x plus 1. In this case, u will be equal to x to the power of 2 minus 2x plus 1. And so u prime will be equal to, if we differentiate this, we shall get 2x minus 2, which is also the same as 2 times x minus 1. So this will be equal to u prime, which is 2 times x minus 1, and then times e to the power of x squared minus 2x plus 1. And that's our answer. Now what if you had the derivative of 4 times e to the power of 3x squared? How can you solve this? This can also be written as 4 times the derivative of e to the power of 3x squared. So in this case, u will be equal to 3x to the power of 2. And so u prime will be equal to, if you differentiate this, you get 6x. So this will be equal to 4 times u prime, which is 6x, and then times e to the power of 3x squared. Now 4 times 6 will give us 24. So this will be 24x, and then times e to the power of 3x squared. And that's our answer. Now you find the derivative of e raised to the power of tangent x. In this case, u will be equal to tangent x, and so u prime will be equal to, when you differentiate tangent x, you get secant squared x. So this will be equal to u prime, which is secant squared x, and then times e to the power of tangent x. Now let's say you are told to find the derivative of 2 raised to the power of cosine 2x. How can you differentiate this? Now notice that in this case the base is not e. And if you remember, we said that if you have the derivative of a to the power of u, this will be equal to a to the power of u times u prime times natural log of a. So in this case a equals to 2, and then u equals to the cosine of 2x. Therefore u prime will be equal to, now how can you differentiate cosine 2x? We know that when we differentiate cosine, we get negative sign. So we shall write negative sine 2x. And then we shall multiply this by the derivative of the angle. Our angle is 2x. When you differentiate 2x, you get 2. So this will be multiplied by 2. Therefore u prime will be equal to negative 2 times sine 2x. So this will be equal to a to the power of u, which is 2 to the power of cosine 2x, and then times u prime, which is negative 2 times sine 2x, and then times natural log of 2. Now let's look at our last example. Let's say we need to find the derivative of x to the power of 2 times e to the power of 3x plus 1. Now to differentiate this, we shall use what we call the product rule. Whenever you have the derivative of u times v, this will be equal to u prime times v, and then plus v prime times u. In simple terms, you differentiate u and keep v constant, and then differentiate v and keep u constant. So this will be equal to, if we differentiate x to the power of 2, we shall get 2x, and then we shall keep e to the power of 3x plus 1 constant, plus, now we shall keep x to the power of 2 constant, and then differentiate e to the power of 3x plus 1. And if you remember, we said that if you have the derivative of e to the power of u, this will be equal to u prime times e to the power of u. So in the case of e to the power of 3x plus 1, u will be equal to 3x plus 1. And so u prime will be equal to, if you differentiate this, you get 3. So this will be u prime, which is 3, and then times e to the power of u, which is 3x plus 1. So this will be equal to 2x times e to the power of 3x plus 1, and then plus 3 times x to the power of 2, and then times e to the power of 3x plus 1. And at this point, we can take out x times e to the power of 3x plus 1, because it is a common factor. So we shall have x times e to the power of 3x plus 1 into, for the first part we shall remain with 2, and then for the second part we shall remain with 3x, and that's our answer. Therefore, that's how you can differentiate exponential functions. If you have found this video helpful, don't forget to like it and also subscribe to my channel. Thank you for watching and have a nice day.